The thing is, you have to give some discount for holiday lunch. I mean, festival lunch. That too being on a Saturday.
Yeah. Very good evening, friends. Welcome to you all for today's meeting. The discussion is going to be, the presentation is going to be on sustainability related codal provisions by Dr. S. Raghunath. I request Shrikant Chanal, Secretary of the Bangalore Center of ACCI, to kindly welcome all the participants for today's meeting. Shrikant Chanal.
Thank you, sir. Good evening to everyone. I take this opportunity to welcome one and all for this 8th session of our Sustainable Engineering series. In fact, we have heard so many technical parameters from Dr. Rajit Sabnis, Dr. Kalgal, then Mr. Engineer
Kalbavi.
Kalbavi and Rajkumar.
And Rajkumar from Hyderabad. So all the technical things we got it from Dr. Ajit Sabnis sir regarding this sustainability aspects, greenhouse effects, so many terminologies that are useful for civil engineers. And today, the building construction. So I welcome one and all, and everybody may be very eager to hear Dr. Ravindra, and maybe today being the fair, everybody is comparatively free, I believe, rather than in the festival thing may be okay. Only thing is maybe little heavy lunch or anything because of the festival. It may be little difficult to digest, but being a good, interesting subject, I hope everyone will enjoy the lecture. And back to you, sir. Raghunath, sir.
Thank you, Mr. Chana. Today's presentation will be made by Mr. Raghunath. I request Mr. Anjaneya Murthy, MC member of Bangalore Center of ACCI, to kindly introduce Mr. Raghunath to the participants.
Thank you, sir. Thank you, sir. Good evening, all. It's my pleasure and Raghunath, sir. He's a professor and Department of Civil Engineering in BMS College of Engineering. Sir has obtained his Bachelor of Engineering in Civil Engineering and Master of Engineering in Construction Technology from UEC and PhD from the Structural Engineering Division from Indian Institute of Science under the mentorship of Professor K.S. Jagdish. Sir is passionate about teaching, research, and consultancy. Interest includes structural masonry, experimental dynamics, earthquake resistance buildings, alternative building materials, energy and buildings, restoration and structural strengthening of heritage buildings, and he is actively involved with Nivasa, an architectural NGO working to enable human and dignified housing condition for the urban and rural through designs. Thank you, sir. I welcome you on behalf of ACCI.
Thank you, Mr. Anjaneya Murthy. Friends, the previous 7 sessions on Sustainable Engineering series organized by Bangalore Center of ACCI delved extensively on holistic aspects of sustainable development, the sustainable development goals, the global issues, the environmental issues, alternative materials, green construction, quantification of sustainable indices, issues pertaining to scarcity and depletion of resources, water, and other materials, sustainable development using concrete, future trends and targets, and so on. All of us have been hugely benefited by the wealth of knowledge and information shared by the eminent speakers. Today's presentation by Dr. S. Raghunath is on sustainability-related codal provisions. He will be covering NBC 2016 provisions, followed by several case studies. The case studies are drawn from implementation of sustainable construction in houses for below poverty line segments in rural regions and houses or buildings in semi-urban and urban segments. The focus of the case studies is to highlight the importance of understanding the aspirations of the stakeholders and choosing appropriate technologies that address several constraints simultaneously, thereby approaching sustainable development. A broad set of guidelines will be shared based on the personal experience during the execution of the projects cited in the case studies. I now call upon Dr. S. Raghunath to make his presentation on this all-important topic. Dr. Raghunath.
Thank you, Ranganath, for the introduction. Thank you. Okay, and while wishing all the participants a very happy Deepavali, I would like to start off my presentation. Can I share my screen, sir?
Yeah, sure. Go ahead. Is it there or
Yes.
You have the control. Yeah.
Yes, I have control. Is my screen visible, sir?
Yes, it is.
Okay.
Good.
At the outset, I would like to thank ACCE for inviting me to deliver this lecture. The series of lectures which was conducted by or mainly organized by Ajit Sabnis. I believe it was the brainchild of Ajit Sabnis. So I would like to acknowledge him also for inviting me to share my experiences in this. At the same time, I would also like to acknowledge the wealth of information shared by the earlier eminent speakers. It was really very useful, not only for the practicing engineers, it was also very useful for academicians and students. I have shared many of the contents with my students as well. So I would like to thank the earlier speakers for sharing their knowledge with the participants. In today's session, although the title is related to codal provisions, I'm going to discuss about the codal provisions very briefly, not in a great detail. So the lecture content will be divided into 4 parts. In the first few minutes, maybe about 5 minutes or so, I'm going to give a very brief overview of the provisions in part 11 of NBC 2016. Part 11 of NBC 2016. Yeah. Sorry. Part 11 of this NBC 2016 is a new part which was introduced into this code, revised code. It was there also in the earlier thing, but it was not exhaustive and so very extensive as in this 2016 version. That is something which I'm going to very briefly discuss in the because this NBC 2016 is available freely on the open source. I would not like to go into the details because anybody who is going to read through this will be able to understand each and every provision of this part 11. So I'm going to give some of my thoughts on what is there and what is probably what needs to be included. A couple of things which I feel should have been included. I'll just tell about that and again quickly in a couple of minutes or maybe about 3 or 4 minutes, I'm going to discuss something about sustainability as different people understand and as I have understood. Like in the last session, Dr. Kalgal was telling sustainability means different things to different people and in different contexts and different geographical locations. So I'm going to talk about what I would understand by sustainability very briefly. And then I'm going to extensively discuss about some case studies. These case studies are drawn from my experiences while working with as in the academic institution to where I belong, and also to the NGO to which I have been associated since its inception. I'm going to discuss extensively on that. I presume that will be the interesting part of the lecture, followed by concluding remarks. I'm afraid I may have to tell that there are quite a few concluding remarks based on my experiences. I'll quickly go through the concluding remarks after the case study. So let me come to this part one of my presentation. A very brief overview of the provisions of NBC 2016. The part 11 is actually titled as Approach to Sustainability. It does not. It is not titled as Sustainable Development, or it is not titled as Sustainable Engineering or Sustainable Construction. It is just titled very appropriately as Approach to Sustainability. Covers the parameters required to be considered for planning, design, construction, operation, maintenance, and so on and so forth. And all these issues were discussed extensively by Dr. Ajit Sabnis in his earlier sessions. In fact, the first two sessions extensively discussed about several, I would say, terminologies which we were not used to in the earlier, before this NBC 2016 came into existence. The gist of this part 11 is it sends out a clear advice about issues pertaining to depletion of natural resources, emission of greenhouse gases, degradation of environment, eco-balance, climate change, global warming, and so on and so forth. It also very clearly mentions about the inequitable development which is happening right now in our country. So while the first paragraph talks about the positive aspects of sustainability, the second paragraph, which you see on the screen, they are all the negative terms which engineers are responsible for to a large extent. I think that is something which we need to be concerned about. So I personally, I would have thought that NBC should have been a bit less negative on that instead of being so very negative about that. Okay. So in other words, sustainability should be addressed and understood in a very holistic manner. This was extensively propagated by Ajit Sabnis. I would like to thank him once again for his presentation. So my comments on this NBC 2016 is as follows. It covers almost every aspect of sustainability if you try to understand it from comparing with the other codes in the Western countries or our own green building documents and so on and so forth. Of course, like in any code, there are a series of terminologies given in the alphabetical order, starting from adaptive thermal comfort, biodiversity, built environment, disaster, so on and so forth. It talks about embodied energy, environmental impact assessment, green buildings, horizontal sun angle, life cycle analysis, and so on and so forth. Of course, it also extensively talks about sustainability and sustainable development as well, and it gives certain sort of structured way by which sustainable development can happen. The two things which I feel is to be included in the next revision is while it talks about almost everything about sustainable development, it does not talk about reduction in use of construction materials. I think that is the one key thing which is missing. Associated with that one key terminology is it does not talk about lean construction or zero waste construction. I think those are the two important things which hopefully in the upcoming revisions it's going to be included. Whereas in the Western countries, they are already talking about lean construction, whereby they are going to reduce the amount of natural resources consumed when any construction takes place. So that is my quick remark on this. And lastly, on this structure of this part 11, if you go through all these bullet points which I have shared here, I have taken it directly from the NBC 2016 part 11 itself. It is remarkably similar to any of the rating systems which is prevalent, the GRIHA or the LEED or VCVC or whatever. Okay, all these things are there. The sustainable sites, and then external development of landscape, water management, rainwater harvesting, building services and optimization, indoor air quality, and so on and so forth. It talks about every things which any other green rating parameter, the currently used green rating parameter is there. So in many ways, I would say this NBC 2016 Part 11 is very comprehensive, but for the two minor comments which I made earlier. So with that, I'm sorry to disappoint the viewers that my talk is not on the Codal provisions per se, because one can read through the Codal provisions and then get enlightened about the parameters discussed. But I would just like to share some thoughts on sustainability as I have understood over several, I would say several years or maybe several decades. I must admit that there are quite a few books and then people who motivated me to delve into this topic. Of course, my mentor, Professor Jagdish, is always there. One very important information which I would like to share with the viewers or the participants is that the book by J.C. Kumarappa, it's titled as Economy of Permanence. It was the first edition came back way back in 1945. Of course, the subsequent 2 or 3 editions came back a few years later, 5 years later, and of course, the last edition came in 1960. It is one of the most profound book ever written on sustainable development. Very interestingly, in this entire book, the term sustainable never occurs. It talks about sustainable development without using this word. Of course, during those days, sustainable development was not the appropriate word as it has found its relevance in the modern context. Perhaps the word appropriate technology was very often used during those days. And the book by Schumacher, which is very aptly titled as Small is Beautiful, a study of economics as if people matter, was written by Schumacher. I suggest that all civil engineers should read these 3 books. It's very, very important, especially when you want to practice sustainable development and approaches to sustainable development. Followed by that book is Small is Possible. George McRobbie was a student, contemporary, and later a student of Schumacher. He wrote this book called Small is Possible. They all use this terminology as appropriate technologies rather than sustainable technologies. It is only of late, like maybe 20 years or maybe 2 decades earlier, sustainable development started coming into picture. And then today, United Nations has developed sustainability aspects to such a large extent that they have come out with the sustainable development goals, which their speakers have talked about. So in short, the sustainable development is the development which meets the needs of the present without compromising on the ability of the future generations. This is something very generic in nature. I think everybody will be able to understand this. My take on this is there are 2 key concepts which one has to understand. The concept of needs and the issue related to limitations of natural resources available. Natural resources are never infinite. We tend to think that natural resources are infinite in abundance, but we know that it is not infinite. It is finite. The first one is very important, the concept of needs. Here I would like to link it to what NBC 2016 talks about in its preamble. It talks about how people used to practice building construction in the earlier days and what we are doing now and what we should not be doing now and what we should be doing henceforth. So I just want to give a small example of my, probably all of you must have undergone this example. In our own context, maybe about 20 or 30 years back, when my parents constructed a house, they did not find even a need for a fan in a residential building in Bangalore. So they never felt the need for a fan in a residential building in Bangalore. Now today, AC has become a necessity in a residential building in Bangalore. Now, forget about a fan. Even people talk about wanting an AC. I think the needs are getting redefined as development, so-called development happens. I think that is something which we need to understand. We need to slow down on that. We need to understand that there are many things that we don't actually need. But we just have to go back one step and then get back to the sustainable approaches. The second aspect is In one of the earlier sessions by Dr. Kalgal, he talked about the intersection of three aspects of sustainability, which I'm also going to discuss. The cardinal approach to tackling sustainable development is reduce, reuse, and recycle. So the first step is try to reduce whatever you want to use. Okay, if you are constructing something, try to reduce the usage of materials. You are spending energy, try to reduce the use of energy. You are spending expending carbon dioxide, try to reduce the emission of carbon dioxide, and so on and so forth. That is very, very important. These are the two key concepts. The entire part 11 of this NBC, and of course, as I mentioned earlier, all the green rating parameters, it talks about these two. Sorry. About these two, and then converts that into practicable methods. Okay. Needless to mention, I just want to quickly skim through this slide. Among the fundamental needs of human beings, food, shelter, and clothing. Food and clothing are going to consume very less amount of natural resources when compared to shelter. Shelter, I have divided that into two parts: the personal shelter and the shelter when public infrastructure is used. I have given the comparison of the amount of natural resources used by per capita in 70-year lifespan. If you look at the combination of shelter and public infrastructure, it exceeds 400 tons per person. Every person who lives on this earth, okay, is going to consume or displace about 400 tons of materials. That's very important for us to realize. Of course, food is consumed 20 tons approximately. The global average is slightly more than that. The Indian average is slightly less than this. Okay, clothing is also somewhere in the region of 2 to 4 tons. Okay, so needless to mention that civil engineers have got a great role to play in reduction of natural resources. Okay, so of course this is one of the in the earlier session I heard Dr. Ramprakash asking this question: is there any pie chart, and then is there any bar chart which shows that these are the materials which are consumed? Yes, it is there. Even in India, there is this Government of India enterprise, indiasat.com. It comes out with very interesting statistics. How much of steel is produced, how much of cement is produced, how much of asphalt is produced, how much of concrete is produced, and so on and so forth. This I have taken it from the book by Ashby. Needless to mention, you can notice that much of the world's production is concentrating on concrete. Okay, and concrete is dominantly produced by cement, and much of the energy in production of cement and steel comes from coal. Okay, so obviously there is this issue of carbon dioxide emission. A couple of more slides on my thoughts on sustainability. Sustainability has to be understood it can be very easily understood by this Venn diagram. Something which is socially acceptable and economically feasible, it is called as an equitable development. Something which is environmentally friendly and economically viable, it is called as viable technology. If it is socially acceptable and if it is environmentally friendly, then it is called as a bearable solution. If all the three are simultaneously satisfied, then it is called as a sustainable solution. For the benefit of the viewers, I'm going to share this PowerPoint presentation also. For the benefit of the viewers, I've given quite a few examples. It is left to you to understand where some of the probably the processes or the materials or the technology, you can figure out whether it is sustainable or equitable or bearable or viable. I'll just take a couple of examples. For instance, solar panels. People generally tend to think that solar panels are actually sustainable. Very interestingly, solar panels are not sustainable as of now. It might look environmentally friendly, but there are questions on that. It is socially accepted because it's not an individual's responsibility. It is not economically very viable because the energy produced by solar panels are quite expensive as of now. And the energy produced by solar panels are not to the scale which is required for the consumption which we are actually practicing. So let me take up another example. Blended cement is a very interesting example of sustainable development or sustainable approach. It is economically viable. It is environmentally friendly because you are using many of the low energy materials like the blast furnace slag and then fly ash and so on and so forth. It is socially acceptable. it is one of the very good examples of sustainable products. Stabilized mud blocks and mud-based construction, they are sustainable, but they have got a social context. Not all mud construction is acceptable. Very interestingly, this another example, the mini hydroelectric power generation. It is considered as sustainable development, whereas thermal source of energy, people tend to think that it is not a sustainable process, but arguably it seems to be sustainable when compared to the other sources. Okay, so I have just given some examples for you to figure out whether it is socially acceptable, economically viable, and environmentally friendly simultaneously. Okay, so those are my that is my take on sustainable development and sustainability issues related to sustainable construction. Of course, I need to mention that there are two very interesting books authored by my mentor, Professor Jagdish, The Alternative Building Materials and Technology, which gives a whole lot of technologies, especially from the point of view of buildings. And the second book, which is published by BMTPC, is Sustainable Building Technologies. It also gives a wealth of information, so one can go through these two books to practice sustainable projects. I will come to the third part of my presentation, which is the case studies. I'm going to discuss extensively on the case studies. I have divided these case studies into housing projects, individual houses, educational institutions, and others. The others are not much. I'll just make a passing remark on that. This case studies regarding this housing projects and houses, I have divided that into two parts: the rural context, the houses for the below poverty line segment, and of course the next part will be in the semi-urban or the urban context for people who are middle class and upper middle class segment. Here I just want to make a small comment here that very often people tend to think that when you practice civil engineering, it only has to be with respect to mega projects and so on and so forth. There are quite a good number of civil engineers and architects and so many other people who are also practicing civil engineering in the rural context and then below poverty segment. I will just go through a few very interesting examples of how we try to address this issue of this housing in the rural context. This is one of my first case studies. There is this village called as Kottamedu in Kanchipuram district. It is about 70 kilometers away from Chennai. So, although it is in the Kanchipuram district, it used to have about 24 houses. A typical house is something like this: 24 houses for 24 families. It was badly affected by the floods way back in 2015, the November-December floods in 2015, and there is one NGO which is called as Banyan. They found out that the people living in this village had mental health issues because of the lack of, because of extreme difficulties in their housing. The houses were so pathetic that many of the people and even the youngsters were affected. So it was during that time that they approached this NGO Nivasa, to which I am associated. They were trying to find out whether we can help them in constructing their own houses. Obviously, they are very poor, poorest of the poor. They are engaged in catching rats for their livelihood and catching snakes for their livelihood, and little bit of farming and little bit of labor work. They don't have much amount of money to construct their houses. So obviously, we had to think about how they could construct their own houses and then produce their own building blocks and so on and so forth. One of the interesting things were we discussed with them and then understood their aspirations and then discussed how they want their houses to be. And then very interestingly, they accepted that the fact that they can produce their own bricks. I'm going to discuss very quickly about this stabilized adobe. Stabilized adobe is it is nothing but a stabilized mud block made without using a machine. You just need a mold, a steel mold or a wooden mold. You are going to take the locally available soil, engineer it to the required sand content, silt content, and clay content, add the requisite amount of binder in the form of either cement and or lime, mix it thoroughly, pour it into the mold, and then compact it and eject it. You are going to get the blocks. In a way, it is an engineered block made by individuals or the community themselves. But the difficulty here is they have to be trained in how to make this block. Okay, so this was the very interesting part. We trained the villagers, and then they made their own blocks, and then they engaged all the people in that village, all the people in the family engaged in the activities of this stabilization block. For instance, you see the curing process. They diligently did the curing and so on and so forth. Eventually, they were able to construct their own house. Okay, so from the 2.5-foot wall, they were able to construct a 10-foot wall. So that it was meeting their aspirations. Of course, there was also financial support from local donors and the government. So that was used for utilizing to provide certain services like doors and windows and the sanitary connections and bathrooms and toilets. But the important thing is they were able to produce their own bricks using locally available soil and very marginal amount of binding material. So that way the cost of the building came down dramatically. They could afford to construct such a big building. I think that is the that's the takeaway from this project. They were all eventually happy, and today there are 15 families who have constructed their houses like this. Very interestingly, I must have shared this. The people from other villages are also trying to emulate this. They want their houses also to be done like this, and they are getting trained on how to make blocks themselves. So this is something which I feel that it's a success story. Okay. I will come to the next example in our own state of Karnataka, near Chikbalapur, between the border of Chikbalapur and Gudibande. There is a village called as Udagiri Nallapanahalli, and that place is has got a good resource of stones available in plenty. Good amount of stones, Sadrali stones are available there. Unfortunately, their houses, there are about 60 families, out of which 25 fall under the BPL category. Their houses are almost like in a ramshackle condition, very poor, okay, very pathetic condition. And when it rains, it is really hell to live in such houses. They also had the major constraint of how to meet their aspirations through cost-effective construction techniques. Very interestingly, slightly well-off houses, they have this very interesting roofing system. They use the stone chapdis. Chapdi is a word which is used to define stone slabs. In Kannada, stone chapdi means stone slabs. Large stone chapdis are supported on the opposite walls, and if the span exceeds, they put a steel girder. And these are some of the practices when they are slightly have got a higher income to afford buying these steel girders. Otherwise, they can't afford even this. On top of this chapdi, they put simply a course of mud concrete, or maybe lime concrete, or brickbat concrete, or cement concrete, depending upon their availability. And then they live in this. This is a very interesting roofing technology which is practiced over there. This is another example. They are very skillful in erecting these stone chapdis. The reason why I'm talking about this is they have got this resource of lifting stone slabs and keeping it on the walls very precisely using a simple derrick, and they are very resourceful. They 3 or 4 people join together, and then they call for the help of the local people, and then lift it and do the job within a day. So the roofing for the entire house will be done in a day, and later the villagers themselves, they put the screed concrete on top of this. The point which I just want to mention is, can you use this skill to make their housing much better in the event that the stone slabs are not available? Now, stone quarrying is also banned, so stone is also becoming quite expensive. In the event that say stone slabs become expensive, could you do something about this? And we train them in making their own beams and panels. Okay, so instead of the expensive steel gird, expensive steel girders, we train them how to make their own concrete girders, just the right amount of reinforcement for the typical span, and provided them with molds for making the precast beams, and another steel mold for making precast panels. And we also trained them to find out whether their quality is correct or not. So this is also very important. So the field testing of their products, they also were very confident, and then they started accepting this technology, and they started making these precast beams and panels. And in this picture, you see that they are erecting their beams and panels. It has got an ease of assembly. The technology is acceptable. You can upgrade the skill. You can generate employment. And in the event that they don't want the roofing system, they can dismantle it and reuse it. It's 100% reusable. So in a way, it satisfies the requirement of sustainable development. That's the point which I just wanted to make about this. Incidentally, you see this, the building is also made of stabilized mud blocks. Here also the walls were made of stabilized mud blocks. We were able to train these villagers in making their own blocks. It's a community project, so all of them got engaged, and you can make any type of block, the full block, the half block, the corner block, and so on and so forth. Use locally available soil and engineer the soil, and then provide the right amount of binding material to get the requisite amount of strength and durability. So this is another example of their house. Very interestingly, you see that the locally available material is used in plenty here. The sill band is made of the Sadarli Chapdi stone, and the lintel band is also made of stone. And in this particular house, they put the roof in using stones itself. The other houses, they either adopted the stones, or they did their own precast RCC beams and panels. So this is an example of that. Okay. So this also falls under the category of using locally available resources and locally available skill set, and upgrading their skill set to make their own houses. Thereby the cost also comes down dramatically. I must say that the technology of stabilized adobe was actually first propounded in Karnataka by Dr. Yogananda, and in one of the villages near Anekal Taluk in Timmayandoti. His technical inputs were taken. Of course, the size of the blocks were quite big. Now we are trying to engineer the size of the block to a very handleable size. Approximately about each block is about 8 to 10 kgs. If you want a bigger block, you can always make it, but the weight increases. People may find it uncomfortable. So this is another example of this sustainable technology. Here is an interesting example of again for a tribal family in Cherkadi village in Udupi district. So of course you can't provide a flat roof here because of the rains. So here interlocking stabilized mud blocks were used with very thin mortar joints. So it is exposed masonry with light roofing system. The roofing was, although it was light roofing Mangalore tile roof, it was not. I mean, it was quite expensive. I must admit that the roofing is an expensive component in this particular building, but it satisfied their requirements and the local requirements. Okay, you can't do a flat roof in this heavy rainfall region. So this is an example of that. Okay. And another example near Kundapura village, Kundapura district, is this again using laterite blocks. So people were trained to use this laterite. They already know how to use laterite blocks. Okay, you just have to provide the right kind of input so that they can use the right kind of right sizes of the block and use less amount of mortar. Otherwise, a huge amount of mortar goes as a base. So this is an example of using locally available resource in one of the projects. Okay. A heavy digression here. Back in Bangalore, there are plenty of people working in construction companies and mega construction projects, infrastructure projects. Of course, I just want to take a couple of minutes. Construction labor colonies, as it exists today in Bangalore, it is again, it's a very abysmal condition. They don't have any ablution facility, sanitation facility, so they are all in a very bad condition. Whenever we talk about sustainable development, we also need to address this issue, because they are all the stakeholders giving fantastic products to us eventually. So it is very important for engineers also to look at the social issues pertaining to these migrant workers, construction workers. So this is one example where the NGO to which I am associated did extensive intrusion, and they made these conditions livable. Okay, a small veranda, the same locally available materials, of course. Using that, the architectural design was tweaked a little bit, and they made it more comfortable. So this is something which people also have to discuss about in forums, in engineering forums. We tend to think that it's a social problem. Architects don't look at it as a problem at all. So mega construction companies, they also don't look at it as a major problem itself, because it's all handled by the labor contractor. So we tend to turn a blind eye towards such things. I think that's also very important. In fact, our NBC also talks about appropriate conditions for the workers involved in construction, and it also links certain key terminologies to the BOCW Act. It's very important. Okay, so although it is not very explicitly mentioned in NBC, it's very important aspect of sustainable development. That's what I feel. Another very interesting example which I would like to share is, there are some technologies which certainly need not be completely permanent nor completely temporary. Very interestingly, when you try to travel around places like Raichur, Bellary, Hospet, and Guntakal, and places like that, there are many technologies or many houses which are constructed using Kadapa slabs. They are clipped together side by side, and then the two long walls are there. The other walls are made using conventional brick and mortar. So actually, although the house looks very rustic and very rugged, it's quite comfortable. It's very important for engineers to learn from the local and vernacular practices. Okay. People tend to think that it's not a good-looking house. Actually, it's a very comfortable house. It's a very long house. Okay, they have got all the amenities built in, and they orient it in such a manner that much of the sunlight heat directly does not fall on the tin roof or the aluminum roof which is used there. So, and of course, they also, when the temperature is very hot, they put thatched material on top of this, and they are also able to get a better comfort inside. It's very important for us to understand this. Very less usage of materials. In fact, it's a lean construction. I would like to put it under a lean construction technique. There is hardly any wet work in this, apart from the front and the back wall. Okay, so very important for us to understand this. Another important issue which I just want to mention here is, in the earlier session, Dr. Kalgal was mentioning about LC3 as the upcoming sustainable cement, the lime calcined clay cement, which is supposedly it is a very sustainable product, because it consumes less amount of energy and emits less amount of carbon dioxide. Very interestingly, use of lime in India has been very prolific just till about 40-50 years back. Later, with the advent of cement, use of lime became very depleted. Very interestingly, people in these places, they mix lime with the pozzolanic material. In a way, it is LC3 itself. This, in fact, BMTPC calls it as a lime pozzolana cement. So lime pozzolana cement seems to be a very promising material, where villages can make their own cement using very low amount of energy, and in fact locally available biomass energy. So here is a small tweak in the design which we did. So the lime pin, which was very inefficient, we tweaked it to the right aspect ratio, the height to the diameter. It has to be between 3 to 5 for the burning efficiency to be very high, and the eventual product has to be burnt properly. So we did this in a couple of places in Chitradurga. Here is one example. So it's a work in process. Recently, a couple of my students have worked extensively on use of lime for especially for mortar applications, masonry applications, and very interesting results are there. I think that it has got a prospect in future. You just have to make this decentralized cement production units, is what I feel. I'll quickly go through the semi-urban and urban segments. Okay. So here is an example of stabilized mud block used for the school in Chikbalapur. This was the school which was constructed by Madam Anita Reddy, the recipient of the Padma Shri Award for the localites over there. The Dwarkanath Reddy Ramanarpanam Trust School. So it's a school, and very interestingly, the need for this stabilized mud block arose because of the lack of availability of good concrete blocks and good burnt bricks locally. So had they wanted to go ahead with the burnt bricks, they would not have got good quality. They had to transport it all the way from either Devanahalli or probably from Bangalore. And if they wanted a good quality concrete block, again, they had to transport it all the way from Bangalore, or maybe about at least 50 kilometers away. So the soil was very good condition. It was very amenable for making a stabilized mud block. The masons were trained to make this stabilized mud block. The architect Kirti Shah of Gujarat was the one who gave this design. The contractor Mr. Amarnath was engaged in this project. So he trained the masons. He had got a set of trained masons, and you see a lot of alternative technologies. You see filler slab technique, and you see a masonry dome over there. And it is the inside view of the classroom. It is exposed masonry, no plastering, reduction in materials, reduction in use of binding materials, less amount of cement, therefore better embodied energy ratio, okay, or lesser embodied energy. So these are the few pictures of that. And such practices are there even in the modern masonry construction. There are many manufacturers who are doing this. Axon, the Besser concrete block, the APCO block, the Basant Beatons, the QCon, the Shobha developers, SV concrete products. Many people are trying to make their concrete blocks and masonry units very efficient. They are making it hollow, engineered hollow concrete block, very high strength, and you can grout it, you can reinforce it. Okay, you can leave it exposed. You don't need plastering at all. So you don't need a beam and a column framed system for most of the projects. Okay, I'll just take a couple of examples. So here is an example. This is a house, a series of houses, about 57 houses constructed by BCIL, the developers BCIL. So they were one of the first to adopt this engineered hollow concrete block. And of course, the lintel blocks are also used for the first time in Karnataka. It's a U-shaped block. You see my good friend Professor Ranganath and also my good colleague Suresh. Ranganath was the one who designed the self-compacting concrete for the lintel blocks. He's testing his own product by standing on it. Okay, so these are the precast products, and this eventually ended up with a platinum rating. So the project is called as the ZEarth project. So one of the prestigious projects of BCIL. Okay. Of course, you also see a lot of other things which are used in this project. Landscaping and indoor air quality, and then use of low energy consuming appliances and so on and so forth. So I must admit that the BCIL was bold enough to sort of experiment with engineered concrete block for the first time. And people who do it for the first time should definitely be bold enough to do that. So the credit should go to them. Okay. And these days there are a lot of clay products also. People tend to think that clay is a topsoil. You are trying to deplete the topsoil. But of course, they consume very less amount of clay, and there are manufacturers use lake bed deposits to make these products. Wienerberger and Lafarge and people, such people, they do this very interesting clay products, roofing elements, columns, beams, many such products they make. Okay, so here is an example, another example in Mysore using engineered hollow concrete block and reinforced masonry, no beams. Okay, so no columns. The load-bearing walls are strengthened appropriately wherever it is required. So this was very actually it was designed for G+3 stories. Now they have constructed G+1 exposed masonry. So although you see it is painted, it's a textured putty. So very less amount of sand was used in this masonry. So that way the embodied energy came down dramatically. And you also see certain very interesting solar passive architecture, small slit ventilators. Okay, all of them are the sustainable practices they practice. Okay, a few examples: residential buildings in Mysore. They got motivated by seeing this building, and they constructed their own house. We found out that the embodied energy is very much less when compared to the conventional framed system. Okay, so During that time, of course, engineer N.R. Ashok was actively involved in this project as well. He was the one who talked about lean construction technique. Okay, and he sort of encouraged one of his friends to construct his house by color coding the amount of material which is required for the appropriate block which is required for the appropriate location. And in a way, it is nothing but the zero waste construction. In fact, this is in my opinion, this is a benchmark building, because the engineer, the electronic engineer, Mr. Nagendra, he did this color coding for his house himself. He ordered 1,420 blocks and 2 blocks extra only to satisfy the civil engineer's ego. And then he ended up with using 1,418 blocks. And these 2 blocks, even now he has kept in this house to show that you can be very precise even in civil engineering. So this entire thing has been documented. I can share this information with any of the participants, okay, through email. So all these things, not a single kg of mortar was wasted, not even half a block was wasted. So every process was taken care of. You can see that there is a small template which ensures that the mortar is not wasted and it does not go into the hollow portion. So that is the lean construction technique which I was talking about. Very interesting case study. Okay. Of course, it's a urban building. Okay. So this is a recent technology, interlocking, dry interlocking stabilized mud block. This entire wall was constructed in a couple of hours up to the lintel level. So architect Rajesh Jain is extensively using this in Mysore and other places. And these days, N.R. Ashok has developed his own product. Very interesting dry interlocking blocks. Of course, dry interlocking blocks does not use mortar at all. Okay, you can construct the entire wall very quickly. So, very interesting product, and it's also amenable to be rightly engineered to be reinforced should you need it. Okay, for taking care of lateral loads and then concentrated loads and so on and so forth. So this is also a very interesting technology. Okay, it's upcoming technology. So of course in Bangalore, lot of examples of stabilized mud block, exposed blocks. Okay, I was associated with quite a few architects. Architect Prasanna Rao. So here is an example of how load-bearing masonry can be as complex as any other structure. People generally tend to think that load-bearing masonry, the plan form should be identical. It need not be. Okay, so you just have to introduce strategically the beams wherever it is required. You can dispense with the columns. Wherever you need a column, of course, you need to provide it. So reduction in the amount of concrete used for columns is a main thing. No plastering is an added advantage. And aesthetic is a social benefit. People accept the technology, satisfying the 3 cardinal requirements of sustainability. Socially acceptable, economically viable, and environmentally friendly. Okay, so this is an example. Of course, Professor Jagdish, Dr. Venkatraman Reddy, and Dr. M.R. Yogananda, they are all the people who extensively have been trying to improve this technology over several decades. So here is an example of that. And you can make a whole lot of architectural embellishment in such buildings. I think I come to the last case study. Okay, so this is again a very interesting case study. One of my student, while she was working on her PhD thesis, she took up a case study, a live project. So this is a residence of Mr. Ramesh Kikeri in Mysore. The embodied energy is just about 1.0, 1 gigajoule per square meter. In fact, he targeted to reduce it to less than 1 gigajoule per square meter. I don't know where he exceeded this. Even today, he keeps talking about this. So he wanted to tackle embodied energy to be less than 1 gigajoule per square meter. So it was just about that. Very interestingly, there are many other features in this building. This particular building, this residential building, it has got near zero sewage discharge, full solar heating, and then it has got a full rainwater harvesting capability in a typical 12 meter by 18 meter building. So this is done. And in my opinion, again, it's a benchmark structure, okay, for residential buildings. So one can go and visit this. It's well documented. So there is also some information available on the open source. Mr. Ramesh Kikeri would be more than glad to share this information. This is a very interesting example in an urban context how you can practice sustainable engineering. Okay, so of course, I just want to take this last slide by Dr. B.N. Varsha. She found out that load-bearing masonry is very sustainable, both in terms of, when I say sustainable, of course, the embodied energy is also less, the cost is also less. There are plenty of choices for that. Okay, you can use a variety of engineering masonry products, right from stabilized mud blocks, stabilized adobe, engineered concrete blocks, engineered clay blocks, and partially engineered, partially load-bearing systems, and so on and so forth. There are plenty of choices. Okay, so as you move to towards the right hand side, the embodied energy is higher, and you can divide this into the 4 quadrants. This is similar to the work also done by Dr. Ajit Sabnis. So you have got plenty of choices. Okay, so you can play around with this, and of course, for multi-storied buildings, masonry may not be appropriate, but up to 5 stories, using the locally available materials, one can practice this technology. I think I'm running out of time. I'll quickly skim through this. I'll come to the last part of my session. I'm afraid the concluding remarks is not a couple of slides, but quite a good number of slides. I'll go through each and every one of them. Whenever we practice sustainable construction, okay, there are some things which we need to understand. When we develop the technologies, we need to ensure that it reduces the quantum of material used and the embodied energy and everything. The embodied energy should be lesser, the material consumption should be lesser, the cost should be lesser, the ease of construction should be there, the manpower should be very comfortably provided with the technology. You should be able to reduce, reuse, and recycle. This is the fundamental tenets of sustainable practice. So that is very popularly called as the 3 R's of sustainable technology. And within this is the fact that you need to exploit local resources, local human resources, local materials, local machinery, local skill set, and so on and so forth. And if possible, try to enhance their local skill set and provide opportunities for them to earn their own money in construction activities. Capital intensive technologies should be avoided as far as possible because they are very sensitive to time overruns. Okay. So here is, I call this as a very disproportionate technology. Here is an example, of course, a government project. They have used monolithic construction for construction of single-storied buildings. I think, in my opinion, this is a very disproportionate technology. Of course, monolithic construction is a fast-track construction for construction of multi-storied buildings in the rural context. In a rural context, you try to put a completely concrete building, which is not even needed for a single-story building. I think it's very disproportionate. And then, in the garb of trying to make this fast-track construction, you try to do this. Okay. Unfortunately, most of the fast-track construction in Karnataka, though the construction could be fast-tracked, the services are not provided. In the end, almost 2 to 3 years, the building is left unoccupied. I think that is something which we need to think about. You don't need to make everything fast-tracked in nature. So you need to talk about a whole lot of things. Till the entire services are introduced, it cannot become a complete building. 4 walls and a roof will not become a building. That's very important. Okay. So you need to, as I mentioned earlier, sustain employment, generate employment, upgrade skills, open up new skill sets. It's also very important. And cooperative movement technology is very, very important. Okay, so this is a ferrocement factory in Sholingur. They produce huge amount of ferrocement elements for the community toilets after the Swachh Bharat Abhiyan and the open defecation free movement. A lot of requirement is there for erecting hundreds and thousands of toilets all over India. So this is one factory where they make these ferrocement products. Okay, it's very sustainable technology in my opinion. Okay, this is I taken this photo by N.R. Ashok, the master planner in Puttur. He is also trying to. He's not trying. In fact, he is very successful in producing these ferrocement products. Employed women in construction extensively, very comfortable working conditions. It's a factory mode construction, production of building products. Very interesting. Just like people work in a textile factory, there are people working in this factory producing ferrocement elements for a whole lot of civil engineering requirements. The roofing, the flooring, the furnitures, the wardrobes, doors and windows, and so on and so forth. Very, very, very interesting. Again, it's a cooperative, friendly movement technology. Quickly, I just want to tell that you need to avoid trusting new technologies for the masses. Okay, this is something which any new technology we tend to use it for mass housing construction. In my opinion, it should not be like that. I think it has to come the other way around. Elite segment of the people or economically well-off people should accept the technology, and then it should trickle down. And do not use new technology projects for field trials. Okay, first you need to carry out the field trials for individual houses and then implement for mass houses. That's very important. Needless to mention that. Okay, laboratory results alone are not good enough to transmit the technology from the laboratory to the field. Okay, till the field trials are done, you should never impose this. For example, I was talking about this lime pozzolana cement. In laboratory, it seems to be giving very interesting result. But in the field, there could be some other issues which we may not be knowing. I think it needs some amount of incubation period before it becomes a product. Okay, that's very important. Adopt culturally sensitive technologies. Housing should not be driven by modularity. Very often, most of the government houses, they are exactly identical. People would not prefer such kind of houses. They desist from going there. So it should not be driven by modularity. That's my personal thought. Develop technologies that helps the house to grow. In fact, constructing a house in phases is actually accepted in India. In fact, even I think most of our generation know that our houses were never constructed in one shot. We used to construct, our parents or maybe our grandparents used to construct a small house. As the family grows bigger, they would start adding more rooms and then probably add more floors and things like that. Okay, so you don't need to construct one big house thinking that you may need it for the next 50 years. I think that's very important for us to understand this. Again, it goes back to the key concept of sustainability. What you need now is what you need to construct now. Okay, that's very important. Every house has got a temporal and spatial acceptability. This is one of my favorite pictures which I show it with my students. This is almost a 5-decade-old building. It's a monolithic concrete construction in Baswangudi in Bangalore. There are two identical buildings there. When one of the building was demolished, to my shock, I saw that the entire building was constructed in monolithic concrete. It was done way back 45 years back. Okay, I was shocked to see this. Okay, it was not that the people did not know about constructing their houses with monolithic concrete. A few experiments were done like this. Probably they found it very expensive and they switched over to masonry and probably RCC and things like that. Again, now it has found relevance. Monolithic concrete has now found relevance in multi-story buildings. Of course, you need to discuss about maintenance. Maintenance is a big issue. Okay, and it's again an energy guzzler. Okay, not only cost guzzler, it's also an energy guzzler. Okay. Do not use natural disasters to kill technologies. Here is an example of an RCC building which is badly damaged and fell during the earthquake. A precast engineered building and a masonry building. All the three major types of construction in India, the engineered construction in India went through this horrible disaster. It's not that RCC is bad or it's not that masonry is bad and things like that. You should not write away technologies. You have to learn from the failures and then try to improve them. Okay, so it's very important that you learn from the vernacular construction. Okay, here is an example of where containment enforcement or the earthquake resistant masonry can be learned from the vernacular practices. Okay, so integrate building technologies with other services. Very, very important. Until and unless the entire services have been provided to the houses, they are not complete. So it cannot be a product for living. Okay, so avoid cartel technologies. So do not sell new technologies. We need to educate people. That's very, very important. Okay, I think Professor Ashwath is going to talk about role of education in sustainable development in the upcoming session. Okay, do not give as-built houses. Try to promote build like you build as you like houses. Okay, that's what I discussed in the earlier few case studies. Okay, this is again unacceptable. These are the typical houses. There are hundreds and hundreds of such houses which are lying vacant from several years. In fact, quite a few of them are vacant from several decades. Okay. I'll just quickly run through this. Okay, last comment, or maybe last but one comment. Striking a balance between the aspirations of the people, the possibilities, the engineering possibilities, and the demands imposed, okay, are the most difficult thing, okay, within the framework of sustainable development. Okay, so trying to balance all these three things is the most difficult in my opinion. Okay, so one can achieve this with lot of pre-planning, as Dr. Ajit was mentioning earlier. The pre-planning stage, okay, and the planning stage. There's a term which I have used, pre-planning and the planning stage, very, very important if you want to end up with a sustainable engineering product. Okay, technology is, of course, is not a panacea for solving housing problems, just a part of the solution. Most often, it is also a part of the problem too. Okay, we now know that OPC is a problem. Okay, it's not only a solution. Okay, so now people are moving away from OPC. So, lastly, while we talk about reduce, reuse, and recycle, we also need to talk about refuse technologies which are not sustainable. Probably reinvent and rethink about our approaches. Probably we may also have to repurpose the existing technologies, buildings, repair them, rehabilitate them, retrofit them. Lastly, we need to respect natural resources. Thank you. Yes, sir. And,
well, thank you. Thank you very much, Dr. Raghunath. That was very, very interesting presentation. These things are going on around us. Well, the sustainability thing introduced into this, and we realized a lot of benefits in the practices that are being done currently. Thank you very much for your presentation. Friends, I think before going to the question and answer session now, I think Secretary of the Bengaluru Center of ACCI would like to share some of his thoughts. Mr. Chanan, you can unmute yourself.
Yeah. Yes, sir. Thank you, sir. Very interesting and informative session by Dr. Raghunath, sir. Quite interesting buildings, projects, and eye-opener for all engineering fraternity to understand and practice. And also his words like reduce, reuse, recycle, and using of local materials, local skill set, everything was quite convincing and interesting. It is the only thing that most of the things what I observed was in village scenario are more than in the urban area. Of course, there are few buildings which have been done in urban area, but now the thing which I am going to discuss about is this is not just sufficient to do the building portions of this technology or non-technology or reject or accept, not the only thing. What we should also know is what is this bylaws and what are the engineers are competent and what practice they are supposed to do. At the end, doctor shows some of the collapsed buildings. It is not just collapsed, but why it has collapsed, who are responsible, why they are not held responsible, and all those things have to be set right before we venturing into the field. We should know the bylaws, because in one of the very competitive architectural building selection this thing we attended, the building was so excellent, everybody appreciated. Finally, I asked only one small question: has it been built as per the building bylaws? Everybody was stunned and there was no answer, and they said owner has not asked for it. Why owner will not ask? But what are you doing? You are supposed to follow the land of the law. And if not following, okay, your building is beautiful. What about the others, the neighbors? If you are occupying the, and eating the full setback of one side and making your building beautiful, What about the other fellows? What about the ventilation of the others? See, this is also one of the responsibility of our engineers to understand the bylaws and to understand the responsibility and what the system should be there in place. It is there or not there. Then to rectify the system to be in place. What are the norms? What NBC says about it? What our bylaws says about it? So these are all coming under professional series, which we are again starting as a next, in continuation of this sustainable engineering series. We are starting up this professional engineers series kind of a thing, which deals with all the other aspects of the professional issues. And I think it will be quite interesting for the younger generation, especially, to understand what he or she should know when they come to the field directly to use it, whether they practice architecture, whether they practice structural design, whether they practice construction, whether they practice whatever the construction related PMC, etc. They should know the minimum professional issues, professional responsibilities, and then only they can become successful in all respects. And with this few words, I request all the members to bring more members and take benefit of our next forthcoming series starting from December. Thank you very much, Rangnath sir. Back to you.
Thank you, Mr. Shrikant Chanal. So we can look forward to many more such things from Bangalore Center. Thank you for that. Now, friends, the floor is open for questions. I call upon Mr. Shivalinga Gowda, who has put forth a question in the chat box. Mr. Shivalinga Gowda, are you there?
Yes, sir. Good evening, sir, and thank you for the opportunity. And firstly, I thank Dr. Raghunath, sir, for his excellent illustrative lecture and presentation. So my question is, I think we saw the villagers' self-help participation, and then they have done an excellent job. But in that, my query is just I would like to know about whether was there any target strength for the stabilized block, and was that achieved? That means, and then the size of the block and the weight of the block in that scenario. That I would like to know. And what was the binding material used there?
Okay.
Yes, sir.
Yeah. The houses, they wanted a single storied masonry building. It was designed for G+1, hoping that at some point in time they may get good amount of economic inputs to construct their one more floor in the event they want. So it was designed for G+2. It is in zone 3. So they had to provide a lintel band and the sill band. Okay, so that's very important, and a roof level band also. The target strength of masonry was 5 megapascals, and the size of the block which we use in that project and which we have been using in the subsequent projects is 200 by 200 by 100. It's a square block, so it's a structure bonded masonry, 5 megapascal using a locally available soil. Of course, the soil had to be tested very often. Every time a batch of soil came, we had to test it for the ingredients, the sand, silt, and clay. We had to apportion the right ingredients in that. So we had to engineer the soil. The binder which was used was cement. Okay, so the 7% was cement was used. So
okay, sir.
And the of course cement 7% was used not from the point of view of compressive strength as such. 7% cement and well-made block is going to give good amount of strength. The 7% cement was required for the durability purpose. Okay, so it is a heavy rainfall region. Okay, so we did not want the rain to erode the surface because it's a plaster-free surface. Okay, so it's to answer
yes,
your question, it is 5 megapascal and 7% ordinary Portland cement.
Yes, sir. Because I think the thickness is the main this one constraint.
Yeah. The weight of the block is 8.2 kgs. Each of the block was 8.2 kgs.
Okay.
Yeah, that is one of the quality check which they do. Actually, when they make this block and they weigh it, it has to be 8.2. If it is less than that, it means that they have not densified it.
Yeah.
That's important.
So that's what was the method they used for compaction, sir?
Hand compaction. It's a stabilized Adobe. It's an Adobe process. It's not machine compacted.
Yeah, correct.
So,
In that, was there any just wooden?
There is a wooden mallet which was used as sort of a tamping tool, and we trained them to do it in 3 layers, but they used to do it in more layers, and they used to do it very rigorously. You know, when they are excited doing their own houses, they do it very rigorously.
Yes,
so I have got very interesting videos and pictures about that. Okay, so
I think it was a very successful story. What we learned. Thank you.
Thank you, Mr. Gowda. Dr. Raghunath.
Yes, sir.
Just a small question. Why is it called Adobe mud block?
Okay. Adobe means actually it is unburnt brick is called as Adobe. So when you make this brick and if you leave it unburnt, then it is called as Adobe bricks. So Adobe is a name for that. And because this is not a burnt brick, it is called as Adobes. Because we have added a stabilizer cement in the form of cement, it is called a stabilized Adobe. Okay, so Adobe by definition is unburnt brick. There are 2 types of mud construction: the Adobe construction and the cob wall construction. In the cob wall, the bricks are made on the wall itself. It is like a monolithic construction. Okay, so the mud is placed using a mound. Okay, on the in the place where the wall is located, and then it is rammed over there. It goes there. Okay. So a rammed one is called as a rammed earth construction. If it is not rammed, then it is called as a cob wall. This is Adobe.
Thank you. Mr. Channa, you have a question?
Yes, sir. I have a few questions for you. Number one, have you tried these blocks, soil stabilized blocks by using black cotton soil is question number 1. Number 2, see this, especially northern Karnataka, Raichur, Bellary, Bijapur areas, black cotton soil is very prevalent. And for, that because of the Mount Morellanite content, the swelling and very much aware how you have prevented, if you had any experience doing the project there. And the third question is, what is your experience with respect to the urban and the villages? Because villages comparatively, you don't have much problem with regards to the space. Whereas in the urban area, the space is the major constraint, and your wall thicknesses and other things may be very costly affair when you compare with the cost of the, in Bangalore, for example, the cost parameters are so high. For that matter, any city, not only in Bangalore. So these are the 3 questions just I want to hear from.
Okay. The first question was related to black cotton soil, how to use black cotton soil for making stabilized mud blocks. I'm afraid I don't have any experience on using black cotton soil for making stabilized mud block. There have been people, Professor Jagdish and Yogananda and others, they have worked extensively in that. They have learned that cement is not a good stabilizer for black cotton soil. It's a lime which is a better product for black cotton soil. Beyond that, I can't answer much on this black cotton soil. Fortunately, in the projects which I was involved, we did not encounter black cotton soil. And in the event, we ended up with a soil which was a very high clay content. We used to avoid it. We used to go for clay, soil content having lesser clay, good amount of silt and sand. Okay, so fortunately, we did not come across that. Okay, so black cotton soil, I know that it's a problem. Okay, so I'm afraid I'm not the right person to answer that. Sorry about that. The second question, I did not understand your second and third questions properly. Can you come again, please?
Oh, sure, sir. The second
ask
question.
Only one question, please. Yika, ask only the second question first. Don't mix the questions.
Okay, sir. Sir, this black cotton, that was related to the black cotton soil only. there is a swelling and a kind of expansion and contraction will be taking place in the ground itself. That is the reason why the plinth level, there will be one slab in areas like Raichur, Bellary, and all, wherever the black cotton soil is there. But when you want to have the sustainability aspect there, have you tackled any problem with regards to that?
No, sir. No, I am afraid I have not. I don't have any experience in that. So
Okay.
I'm not the right person.
Okay. The
Can
third
I
question
answer to
was,
that, sir?
Sorry.
Hello.
Who is it?
Yeah. No, I'm Shulingagoda. I would like to share my thoughts on that.
Yeah, go ahead.
Yes. Go ahead, sir. Please go
Yeah,
ahead.
regarding this one, the swelling and then the expansion contraction situation in the black cotton soil whenever we are opening for the foundation purpose. First, we have to stabilize through the sand piling we used to do, and then we are going to stabilize that, and then we are going to take up the work, other foundation work. Otherwise, it would be difficult for to maintain that or to arrest that expansion contraction. That means the cracks are going to come and then it's going to sink and variation in the differential settlement is going to happen. As far as the stabilized soil blocks are concerned, I think the ingredients, what Dr. Raghunath mentioned, if we maintain that, that means if we study the whole characteristic of the existing soil and then what are all the ingredients we have to add. So with that, and then the lime is the right material for the binding. With that, I think we can always have this. But the only thing, the strength of the blocks are going to be not more beyond. We can't expect very good strength in that. So within that limitation, if it works, because as Sir was mentioning about only ground plus one, I think it could be done. That's what my experience.
Thank you.
Okay.
Thank you,
Thank
Mr.
you.
Shulingagoda.
Thank you, sir. So the last question from my side was, what is your experience with regards to the space constraints in urban areas? Because in villages, you will get sufficient area. These blocks will always consume more wall width because we will be having here 6 inch and even less than that. But in the blocks, what you are showing, maybe the width will be more. Do you have any experience in urban area and villages? Have you compared?
Sir, of course, I'm fortunate to have worked both in the urban, semi-urban, and then rural context. In the urban context, unfortunately, my limitation is I have worked only extensively on engineered masonry structures. The least wall thickness which I have gone is 125 millimeter, or a span of 4 meters. 5 inches is the wall thickness. You can construct 4-meter span rooms and then buildings with 125 wall thickness. Of course, the masonry has to be designed for that. Okay, it's an engineered masonry. You can go up to 4-story without any need for RCC beams and columns. So in the urban context, there are so many variety of technologies where wall thickness can be reduced. So again, I'm afraid my limitation is that I have worked extensively on masonry, not on concrete.
Okay, thank you, sir.
Dr. Raghunath, this 125 you are talking about,
Yes, sir.
were these designed for load bearing?
Yes, sir. It was designed for load bearing. Yes, it was designed for load bearing. There are two manufacturers who did this. One is, of course, the Axon Concrete products, and the other one is, of course, earlier there was Besser Concrete, and then there's also this SV Concrete products. They also did this. It's a 7.5 megapascal, the prism strength of the masonry.
Okay, thank you.
Engineered blocks, sir? Engineered blocks.
Engineered blocks, yes.
Engineered.
Yeah. Was there any reinforcement in the corners or in between? Maybe.
It was needed in the corners. Okay. Though it is not mandated in the code, in Bangalore is in seismic zone 2. Though it was not mandated in the code, just for the sake of structural integrity, we provided the reinforcement in the corners. Okay. So and there was a thin band of reinforcement at the sill level and the lintel level.
Okay. As far as the earthquakes are concerned, was that the point was concerned? Is that
No, this is in zone 2. Okay, it did not need the additional earthquake resistant features in the form of vertical reinforcement.
okay, sir. Thank you.
Okay. Any other questions? Other members? Okay, I think one Miss Divya had a question there, or is it just a statement? Miss Divya, are you there?
Okay, I get the question, sir. If we construct wall use of RCC for one story, why it is not good? The point is, I did not mention that it is not good. I said it is not sustainable. Okay, a single storied building, you don't need so much of concrete. Is what I was trying to tell. Okay, it's a disproportional technology. I call that as you don't need concrete, monolithic concrete for a single story building. While when you can do it with so many other sustainable alternatives. That's the point. Okay, I'm not per se against concrete construction. Okay, so that's the answer to the question by Ms. Divya.
Yeah. Okay.
Yeah, Dr. Raghunath.
Yes, sir.
Ajit here.
Yes.
This is slightly away from the topic what you have discussed, but since you are connected with the academia, and I just want to know what is their views. Suppose with the advent of artificial intelligence, which is coming, do you think that artificial intelligence will help to build a better climate and sustainability models?
Okay.
It's just a random question, and then inviting your views on that, because I feel that this is going to, whether I like it or not, artificial intelligence is going to play a kind of a havoc in our future technologies.
I'm not sure how I will go about answering your query. Okay. First of all, the cutting edge technologies in the information science and the computer science, which is nothing but the artificial intelligence, is really not so very cutting in even in the manufacturing process, in non-civil engineering manufacturing process. It is still a long way. It is still got a long way to go in construction. I don't know, but coming, I mean, trying to answer your question in a rather rustic manner. Okay, if you try to go through this our NBC document, it talks about going back to the vernacular construction practices. I don't think we need artificial intelligence. I think we have to use our native intelligence and traditional intelligence. Okay, so we don't need to be so very intelligent to construct simple buildings. Okay, is what I feel.
Okay.
Mr. Narayan Swami? No, Nanjun Swami. Mr. Nanjun Swami, you have a question? Okay, Dr. Raghunath, you're just mentioning about the codes while talking about the engineered blocks. Can you just tell us about the codes that are available, if any, on the engineered blocks to be used as load-bearing structures?
Yes. Of course, NBC 2016 now has got a dedicated section for masonry. Now, for the first time, the reinforced masonry code also has been updated and included in NBC 16. So, part 4 of NBC 16 is completely dedicated for engineered masonry. One can go through that part 4. Should somebody need it, I can always share it. Okay, they just have to mail me. I'm going to send it. So there are codes for production, and then specifications, and then quality control of mud blocks, stabilized mud blocks as well. That's also there. Okay, so there are codes there. Fortunately, there has been a significant progress in masonry of late.
Right. Thank you very much, Dr. Raghunath. That was very interesting, and I'm sure all of us have benefited a lot from this particular lecture. I now call upon Treasurer of Bengaluru Central.
Raghunath, just
Dr. Ashok. Yes, sir. Yes, sir. Please.
Professor Raghunath, it was a very excellent presentation. I've also closely associated with constructions like what you mentioned. And as Shubhadev was talking about clay soils in Bangalore and surrounding areas, people use sand piling and cassuna piling to stabilize the base. But as far as the mud block construction, they normally, when such soils come across, they replace the soil itself approximately about 50%.
Dr. Ashok, I think you have network problem. Hello?
Can you hear me?
Yeah, you got cut in the middle.
Okay.
There
were some efforts to make a masonry society and consolidate all the knowledge base available to promote masonry structures for up to ground plus 3 or ground plus 4 structures. Anything happened in that direction?
Yes, sir. Okay. Actually, of course, you are also one of the triggering persons for that. Almost a decade and a half back, you and Ashok, NR Ashok, and then Professor Jagdish. So you are all the people responsible for us to create a small center here called as a Structural Masonry Resource Center. If you notice my slides, it has got SMRC. SMRC stands for Structural Masonry Resource Center. We have been trying to advocate and then sharing knowledge on masonry related issues. Anybody who wants any information regarding engineered masonry, earthquake resistant masonry, and design of masonry structures and things like that, we'll be more than glad to share our information. So the Structural Masonry Resource Center is there right now in BMS College of Engineering. Of course, we have got active people working elsewhere as well. So it is not a registered body, but it's a part of BMS College of Engineering.
Okay, thank you very much.
Okay. Thank you, Dr. Ashwath. I call upon, is there any other question? If anyone is interested, we can take one last question if anybody would like to pose a question. Okay, thank you. I now call upon the Secretary, Mr. Shrikant Chanal, to propose a vote of thanks for today's presentation. Mr. Chanal?
Yeah. On the outset, it was a wonderful discussion, and being this festival season, it was we were a bit worried that whether our viewers will get time to participate or not, but was a good response, and I thank everyone for being attended this, and hope they have got a good benefit out of all these lectures. And of course, we all have to thank Dr. Ajit Sabnis for his meticulous planning of this series. And now I await for the next sessions that we are going to start from December. I hope everybody is benefited. Thank you very much. Good night.
Thank you. Thank you, Dr.
For our other discussion, shall we?
Sir Ranganath, I just have a small request.
Yeah, Mr. Dr.
Yeah, I will send my PowerPoint presentation to you, or maybe to ACCA. You can share it with the participants, please.
Sure, sure. Yeah.
Raghu, you can kindly mark a copy to me.
Oh, thank you. Yes, sir, I will do it.
Because then it will be uploaded, because I am uploading it.
Yeah.
Yeah,
I'll do it right away as soon as I log out. Thank
all
you.
right, sir. Thank you.
Okay. Thank you. Thank you all. Shrikant Chanal, would you like to have another meeting here or what? Or we can meet later on.
As you wish, sir. That is the reason why I asked about, because everybody, just there.
Ah.
So